In this concept video, we're going to be discussing transformations. Transformations can be a number of things, but basically we're going to be changing the shape of the graph or the orientation of the graph. The two transformations we're going to discuss today are going to be a translation, and all that is just a shift. And we can shift in the horizontal direction, left and right, so maybe I'll write that here. That's the x direction. Or we could do a vertical shift. Oops. We'll go up or down here. We can also do what's called a dilation, or I'm going to list that as a stretch. I'll put that down here. Or a shrink. So let's take a look at this first part here, this translation. In general, we'll recenter this here for you. In general, when we have an equation that looks like this, and this might be a 2, it might be a 3, there might be absolute value bars, whatever the function is. If we look inside by the x, we want to look inside the parentheses by the x or inside the absolute value bars by the x. We want to look inside where the operator is doing the heavy lifting. So the 2 is being applied to this inside part. When that value is right by the x, like this h is, then the shift will be in that direction. So the horizontal shift is just h. Notice how it's x minus h. So let me give you a concrete example here. Let's go with -2, and we'll go x minus 4 squared plus, I don't know, 7. It's x minus h, so h in this case is 4, not -4. It's 4. So that's going to be to the right by 4. The horizontal shift is just h, and all points are shifted by that amount. K is a little different. It's plus k, so k in this case would be 7. So the vertical shift is k. If you have a vertex, then the vertex, the new one, is going to be hk. So new vertex. Some graphs have that, some graphs don't. Every point will be shifted in the direction left-right for h, and then up and down for k. In this case, all the points will be shifted right 4 and up 7. Let's take a look at this value of a. If a is negative, there is a reflection. And it's going to be over the x-axis in this case. Same thing we talked about before. Hopefully you've talked about sine and cosine graphs. And if you have, it's really the same thing that happened there. So if a is negative, there's a reflection. This has a reflection. Instead of opening up, this parabola will open down or be reflected. We could also say, if the absolute value of a is greater than 1, then there will be a stretch with respect to the y-axis, where it will narrow towards the y-axis. Move this up a little bit for you. If the absolute value of a is less than 1, so like between 0 and 1, then there's going to be a shrink, or it's going to look like it's going to widen towards the y-axis, or away from, maybe I should say away from here. So when A is a little bit bigger, like 2, the absolute value is greater than 1 here, like 2, the effect of this is going to be, a normal quadratic would look kind of like this. The effect is going to be to narrow it a little bit. So you might have a parabola that would be, well, I don't know, right one, up one, the regular one. So that would look, well, things are getting a little busy here, but that would look kind of like this. This function is going to be a little bit more narrow. That's what the 2 does here. It kind of narrows it with respect to the y-axis. This is just kind of a concept video. So when we do these actual problems in the examples, you'll see how that comes into play. But just know that we're going to be discussing translations, which are shifts in the horizontal and vertical direction. And then this value of a does a couple things. So a will cause a reflection if it's a negative, and then it will also affect the shape of the graph in terms of whether it's narrowed or widened out. Not the general shape. The general shape of the graph is directly related to the operator here, which is the squared sign.